is my the first slide, equilibrium. And when designing for a complex feature, you can make two mistakes. The first mistake is oversimplifying a complex problem and then ending up with a product that doesn't address those problems. Or you could simplify, you could understand the complexity of a problem and then you end up with a design, with a final product that it's not well designed enough for the complexity of the problem. Or, as this is the third case, you can get the problem right, and you can make all the information that you need to know about the system or the product available for the user. And this is the third option, the everything right, the problem and the system. So this is a project in a few words. You already know the brief.
I'm sorry. Can you get the lights?
Where was the?
It's the other switch.
Maybe this too much.
There you go.
Okay. So this is the project in a few words. My group, AI and S, the designs, and we will look at each one of those in this order. The communicator device, the cylinder of information, and the activation of the scenarios that I could, like the list of scenarios that I could choose from, and the scenario that I narrowed down in some application. These are the case studies that I used for my design choices. There's the Google Glass, as you know, for the privacy concerns, and the neural technological terminal for the brain computer interface. So my project falls under these categories, main categories. We have artificial intelligence for the chips. Then we have AR, not VR, AR, augmented reality, wearable technologies, because I think that in the future the devices that we're not going to use the devices, we're going to wear them. And one of the examples of a wearable technology is the smartwatch. And consumer products, the products that we use every day. And these categories also happen to be the most profitable business because design opportunities are oftentimes business opportunities. You guys didn't see this map in the research section, right, Jesse? Okay. I'm going to break it down for you. So what I'm doing now is giving you the tools to understand the final outcome of the project. So what I want you to do is not overthinking about the thing, because I'm giving you the problems and the theoretical foundation to understand the final design. This is one of the biggest dilemma when designing for responsible innovation. And what basically this dilemma is about is when a technology is at an early stage of development, you don't know how it will affect society. So you can't intervene on the technology. When the technology is out there in the world, you can understand how it has affected society, but you can't intervene on the technology because it's already out there. And this is the solution that I chose, to inform my design system. And what basically what this solution basically says focuses on is soft impacts. Soft impacts, as you can see, are subtle technology-inflicted shifts in society and user practices. To give you an example, think about the phone. When the phone was introduced, it changed the social acceptability of how we take private conversations in public. And the scenario, let's say the anticipation of effective evaluation, solution is the one that I decided to like focus on for my system. This is the field of design that comes together in equilibrium. We have speculative design because this field of design is all about raising questions. Inclusive design because inclusive design is the field of design that truly designs for everyone. And product design, which is more commercially oriented, and it's kind of the thing, the field of design that I kind of studied in high school. So they all come together in equilibrium. For me, these are the fields that should be involved in AI-related technologies early on. But I wouldn't want these fields to be completely swept away because this field for me should only empower the traditional which are computer science, engineering, and neuroscience. They're not completely eliminated. They just empower the fields that I want to be involved in AI-related technologies. And we have Humanist, which is the love for humans. The subject is always around the humans. Design and philosophy for the ethics of technology. And as Lorenzo said, I consider nothing human is limited, and I also believe in that mindset. You guys remember this? This is the future for which I'm designing, and because in the future, designers might not design products at all. They might design ethics instead. So this is the theory of equilibrium. And in order for this system to work, I had to design the premises of this future. And this is kind of where the fields that I previously showed you to be at this point, at this stage. Because this is the near future. The future in which we are all in the hands of technical people. And the machine has taken over us. This is where we need to be, the philosophers and the designers. And at the end, we find equilibrium, and this product system can work within that future. Okay, a little bit of pop culture. I just disclosed because there's equilibrium in it, and we don't want to become viruses. So take a look at the just to not make it too serious, you know. That's why I do it. So this is the last slide of the philosophy and research section, hopefully. And I don't know if you guys remember this. I just changed a few text here or there. And this is the human gene in this society, the human society. In the AI-enhanced human society, the enhanced gene is still there. It's still on the same level of intelligence. Because as you will see with the activation interface, you will learn how to grow with your AI, like how to grow along with it. And if the interface doesn't make it clear, doesn't make how to do that clear, then maybe I failed as a designer. But you'll see if you guys understand the final concept of the interface on how to do that, how to grow along with your AI. And this is a quote of mine, and this is kind of what we do right now when we use the electronic devices. We interact with them and they get back on us. And they give us feedback, and this project is all about like emphasizing those aspects, but in a really not invasive and really responsible way. Okay, when you showed the slides about mood boards, I came up with this idea. Instead of creating like just a slide for mood boards, I kind of cleaned all the sketches and all the images of the development on the wall, and I created a giant mood board. So these are kind of the sketches of the interframe and the wireframe for the interface and the objects. These are just some of the sketches for the philosopher music aspect, and this is what I want you to focus on, because the final design language is all geared towards these images, is focusing on how I made the things, because these objects are objects whose design process can still be applied to new devices. And we have all the example of great design designs. Willow, the typewriter, all the and this is the what. The close design preferences and materials. Because we have the fabric, the speaker, and the headphones, because you could wear the main piece as a These are the prototypes. You can see the out of form and all of the anyway, let's focus. Okay, this is the communicator device. We will look at the communicator device, which is the main piece. Then the cylinder of information, and at the end the interface. And I decided to put them in order because there's a clear way of explaining these things when they are. So this is the chips, the chips, AI-powered chips in our brain. This is the device that we wear. And this is the world of objects that surround us, all around us. The scenario of self-medication is not here. This is just to show you the potential of what are the objects compatible with the main device. And this is kind of I would say this is the main slide for the communicator device. This is really interesting, guys. Look at this. This is really interesting. This is what we wear now. What we use. We use a headphone, earbud, laptop, computer, and iPhone, and smartwatch. And that is my device. And I kind of had to put something, but it could be as well like completely black, because the only thing that is the only thing that you need to use this device is you. You don't need other objects. It's just you. And you wear the thing as if you were an headphones. So it doesn't change the use behavior. That's why soft impacts. Because it doesn't change the thing you have to approach the thing. It doesn't change the way you have to change your behavior to wear the thing. Because you wear it as an headphone. And sorry. These are kind of the slides of the different sides of the object, because it doesn't have to look good from one preferred view, which is the side view. It has to look good from all different points of view, and yeah, this is basically and at the bottom over there there's my ideas for the materials. This is supposed to be nanomaterial, superconductive, and flexible. And the screen is an OLED screen, and then the normal mesh fabric for the speaker. I'm sorry. Okay, I'm almost done because we just have the cylinder of information and the. So these are the main interactions that you have and the main configuration of the object. So you would use these kind of sensors in inside of this speaker to kind of move the interface around, and this side of the object monitors your RP, kind of like the smartwatch. And this is how you split the object to listen to music, and it also changes the way the configuration the screen is set. This is some of the colors available. Now, this is information. Pay attention to the color because colors also symbol of something. So in the orange section, we have all the different objects. Now the scenario is self-indication, and the object displayed is the cylinder information. The way the cylinder information, which is the container pills, interact with the main device is through the interface. This is the prototype. This design, the designers of today, and this is the design of tomorrow. So why do we need to see the information on the container pills, like every time we see the object? We want to see the information only when we actually have to use the container pills. And exactly what the container pills is for, the interface. And the wave pattern for the interface, and this is the user journey. So the image number 2 and the image number 3, these are the traditional information that we have on the container pills nowadays. These are the added information with the AI. We have the digital presence of the doctor, and then we have the status, the sickness, and all the contacts of the doctor available in our in Chicago. And this is kind of the order of appearance of the interface. Now, how does it actually? This is where the interface, like the position of the interface on the center. How it works with the device. This is off. I'm not close to the cylinder of information. I'm like in another room. As I approach the object, the color changes. And when I actually pick it up, the interface pops up. So the information is not there all the time. Because what if I don't want another person to see that I'm taking those pills? I want to see them only when I have to use them. It works with the device. So it works with you, only with you. Because it's really personal. And this is the design language, because they're all part of our family. And if you see the way I arranged this photo, is I put the cap, the design of the cap of the cylinder, in the same position as I would place the smart device. And I did the same thing with the smart device, as if it was the cap of the cylinder. And you can clearly see the design language is the same. Oh, yeah. What this rendering shows is the fact that different pills will have different colors. So this is kind of my pill for the specific illness, and these are all the other possible colors for other medication. Color plays an important role in everything I did. Last section. I'm almost done. This is the activation interface. So, kind of broken down activation interface. Okay. We have the different section of the interface, and where all the information are displayed throughout the interface. If you guys want to see more of this, I can show it. I can show all the images that you want after the presentation. And we have the screen configuration, so that you can decide how to set the screen with your device. The location info, where you are, like the Chicago and all of that. The learning section, and this is connected to how to go with your AI, the learning section, because you have to learn how to be compatible, how to be more compatible with your AI. And this section of the page shows how, in percentages, the compatibility that you have with your AI, and close to it, the learning section, how to grow. This is the connected communicator device, the orange one. AI human info, how, what kind of information AI is reading about you. And then we have the customization setting to change the color of the interface of the smart device, and the wheel suggest interface. We will look at each one of those, and it'll all be clear at the end. So basically, we don't have time to go into each one of these, but I had to design the activation interface because it makes AI understandable for the average player. So, since I want humanism fields to kind of intervene in the technology of artificial intelligence, I had to make the interface transparent in terms of how the information about you and the AI are displayed. And these are the key aspects of a human AI interface. The customization. You can change the color of both the interface and the device, and the size of the interface in the real world. The biological report. The interface gives you a report on your biological status. Learning how to improve compatibility with AI over time. And if you don't know something, you have all the information at your disposal about on the interface. This is kind of a visual, a visual of the AI and the related compatibility that AI has with you. So as you turn on the object for the first time, AI compatibility is at 10%, which is the minimum working percentage for the interface and the object report. And as you grow, as you learn how to grow with your AI, you will get at 100% when it's completely fused together with your brain, with yourself. And these are the design of the emotions. And I took this scheme from a psychologist and a doctor that worked along with computer science students, and they're going to be displayed in the Now let's take a look at the actual. This is an example of how an interface might look like, because again, you can choose the colors and everything. So the learning section. In the learning section, we have three main categories. You have the productivity categories, the first one, the entertainment category, and the self-medication category. And the self-medication category is one of the categories connected to the cylinder information that I showed you earlier. And as you can see from the description, in this category, you will learn how AI can help you stay healthy by monitoring your mental and physical status. And this is the screen configuration. Is it all coming together from the main thing? Okay, we'll talk about that later. The screen configuration, and this is the various screen configuration of the device, and four configurations for 4 different needs. And these are all the configuration available, and this one is the one selected. Okay, and this is the customization setting. on the interface. So you can change color by mood, either by mood or by outfit. As you change the color on the interface, it changes the color of the object displayed on the interface itself. So this is the basic color orange that I picked. This is the last one, the last slide, guys. Then I'm done. This is the section of the interface where all the AI movement info are displayed. So we have the current tasks of what kind of things AI is doing with your mind and with your self at large in that particular at any given moment. So AI reading emotions, and as you can see, the AI reading emotions status is low. And it tells you what reading emotions mean. AI ability to read your emotions and customize content accordingly. Then we have the biological monitoring, and it's pretty high in this example. And it tells you what biological monitoring means. AI ability to detect beat sparks or anomalies and act upon them. And then we have the learning curve. The learning curve, which is connected to the learning section of the interface. AI ability to change over time and learn from your behaviors. And you can change the level of this. It's customized, you can change it. The likability mistakes, what AI can do and how well it can do it based on the compatibility that it has with yourself. And these icons correspond to those information. AI action setting, efficient dismissal. What does that mean? It means that if you don't want to accept an action that AI is taking for you, you can dismiss the action of the AI. AI data usage, which is something that we don't have on our phones. Where do our data go? What AI is doing with our data? We want to know that. AI accessibility. What information does AI have access to? What does AI know about us? It shows you that. AI compatibility over time, and there's a scan about that. And these are the emotions reader on the interface. The emotions reader visuals that you saw earlier. And these are all the other pages of the interface. These are the distortions that happen when designing an interface for the AR field. This is the interface kind of arranged on the grid that is distorted as we would see it in the billboard. And these are the imaging context. So as you can see, the color of the thing is orange and the scarf is orange. So she probably changed the color by outfit in the customization